This is Melanie Fine of Chem and 10, and today we're going to go over some stoichiometry practice problems. There are four classic types of stoich problems: moles to moles, moles to grams, grams to moles, and grams to grams. This is the general approach. We go from grams of one species to moles of that species. Then we go from moles of that species to something else in a balanced equation, and then we convert that back to grams. Our basic approach is we go from our unit given to moles of that. So let's say we're given grams of hydrogen, we need to convert that to moles of hydrogen. Once we have moles of hydrogen, we need to convert that to moles of something else in the equation, let's say water. So we convert moles of hydrogen to moles of water, and once we have moles of water, we need to convert that to our unit wanted, which I guess in this example would be grams of water. But it's all the same problem. Whatever you're given, just turn it into moles. If you're given grams, turn it into moles. If you're given liters of gas at standard temperature and pressure, turn it into moles. If you're given molecules, turn it into moles. Whatever you're given, turn it into moles. So let's look at a sample problem. We have 5 H2O2, 5 hydrogen peroxides, reacting with 2 moles of potassium permanganate plus 3 moles of sulfuric acid to make 5 moles of oxygen plus 2 moles of manganese sulfate plus potassium sulfate plus 8 moles of water plus 418 kilojoules. And that just means that 418 kilojoules of energy are released. It's usually seen in the form of heat. How many liters of oxygen gas at STP can be produced from 4 grams of sulfuric acid? So we want to figure out how many liters of oxygen that's our wanted, and we're given 4 grams of sulfuric acid. So we need to go from 4 grams of sulfuric acid to liters of oxygen gas. So to solve this problem, remember that we're going to have to convert everything to moles. So if we have 4 grams of sulfuric acid, we're going to have to convert that to moles of sulfuric acid. And to do that, we need the molar mass of sulfuric acid, which we get in the periodic table, to be 98.1 grams per mole. We're also going to need to convert liters of oxygen to moles, and we know that a gas at STP has a molar volume of 22.414 liters. So 22.414 liters of any gas at STP is 1 mole of that gas. And of course, since we're dealing with 2 different species, sulfuric acid and oxygen, we need the molar ratio between the 2. And we know that from the balanced equation, 3 moles of sulfuric acid make 5 moles of oxygen. So now we're ready to set up our problem. Question mark wanted, question mark liters of oxygen is equal to 4.00 grams of sulfuric acid. The 4.00 grams is our given, tells us that our answer needs to be in 3 significant figures. Dot line. To cancel out grams of sulfuric acid, we're going to put grams of sulfuric acid in the denominator. 98.1 grams of sulfuric acid is equal to 1 mole of sulfuric acid. And the grams of sulfuric acid cancel out. Now we're going to convert moles of sulfuric acid to moles of oxygen. And we know that in our balanced equation, 3 moles of sulfuric acid is equal to 5 moles of oxygen. We put the moles of sulfuric acid in the denominator to cancel out the moles of sulfuric acid in the numerator. And now that we have moles of oxygen, we want to convert that to liters of oxygen. And we know that 1 mole of oxygen at STP has a volume of 22.414 liters. We put 1 mole of oxygen in the denominator, which is equal to 22.414 liters in the numerator, and the units moles of oxygen cancel out. We multiply the numerators together and divide by the denominators, and our answer in 3 significant figures is 1.52 liters of oxygen. Sample problem number 2, using the same equation. How many grams of H2O2 are required to produce 5.00 times 10 to the 21 molecules of water? So we want to know how many grams of H2O2, and we're given 5.00 times 10 to the 21 molecules of water. Okay, so we know that a mole contains 6.02 times 10 to the 23rd molecules. So clearly this is less than a mole of water. And then we want to figure out from this, whatever number less than a mole of water is, how many grams of H2O2 we have. So to solve this problem, we need to convert everything to moles. So if we want grams of hydrogen peroxide, we're going to need to know how many moles that is. So 1 mole of hydrogen peroxide is equal to 34.0 grams per mole. We get that from the periodic table. Each oxygen atom is approximately 16 grams, so 2 oxygen atoms is 32 grams, and each hydrogen atom is approximately, each mole of hydrogen atoms, that is approximately 1 gram. So we've got 2 moles of hydrogen atoms, so that's 2 grams per mole. So altogether, it's 34 grams per mole. We're also going to need to know how many moles 5 times 10 to the 21 molecules of water is, and we know that 1 mole of any compound is equal to 6.02 times 10 to the 23rd molecules. And finally, we're going to need the conversion factor between moles of water and moles of hydrogen peroxide. And we see that 5 moles of hydrogen peroxide make 8 moles of water. Now we're ready. Question mark wanted. Question mark grams of hydrogen peroxide is equal to 5.00 times 10 to the 21 molecules of water, dot line. To convert molecules of water to moles of water, we're going to put molecules in the denominator to cancel out the units, which is equal to 1 mole of water. And notice the molecules of water cancel out. Now to convert moles of water to moles of hydrogen peroxide, we know that 8 moles of water in the denominator is equal to 5 moles of hydrogen peroxide in the numerator. And then finally, to convert that to grams of hydrogen peroxide, we're going to put 1 mole of hydrogen peroxide in the denominator, which is equal to 34.0 grams of hydrogen peroxide in the numerator. We multiply the numerators together and divide by the denominators, and we get 0.176 grams of hydrogen peroxide. Sample problem number 3. How many kilojoules of energy are released if 49.1 grams of sulfuric acid are consumed? This seems a little bit off. We haven't dealt with kilojoules of energy, but let's see if we can solve this. We're given 49.1 grams of sulfuric acid, and we want to know how many kilojoules of energy that will release. We know that for every 3 moles of sulfuric acid, we release 418 kilojoules. So I guess we're going to have to figure out how many moles 49.1 grams of sulfuric acid is. So to figure out the number of moles sulfuric acid we have, we're going to need the molar mass of sulfuric acid, because remember, you want to convert everything to moles. 98.1 grams of sulfuric acid is equal to 1 mole of sulfuric acid. And the molar ratio between moles of sulfuric acid and 418 kilojoules is given to us in this problem. 3 moles of sulfuric acid produces 418 kilojoules of energy. So how many kilojoules of energy is equal to 49.1 grams of sulfuric acid? We divide by the molar mass of sulfuric acid because we want the grams to cancel out. So 98.1 grams of sulfuric acid is equal to 1 mole of sulfuric acid. It looks like we're dealing with about half a mole, because if 1 mole is 98.1 grams, so we have about half a mole of sulfuric acid. And then we want to convert the moles of sulfuric acid to kilojoules of energy, and we know that 3 moles of sulfuric acid release 418 kilojoules of energy. So the moles of sulfuric acid cancel out. We multiply the numerators together and divide by the denominators, and we get 69.7 kilojoules of energy. Sample problem number 4. How many molecules of potassium permanganate must be consumed to release 338 kilojoules of energy? This is another energy problem. We want to know how many molecules of potassium permanganate are required to produce 338 kilojoules of energy. So let's look at our conversion factors. We want to convert everything to moles. So we know that 1 mole of any substance contains 6.02 times 10 to the 23rd molecules. We needed molecules because that was our wanted. And then we need the ratio between kilojoules of energy and potassium permanganate. And we know that 2 moles of potassium permanganate produce 418 kilojoules of energy. Setting up our problem, question mark wanted, question mark molecules of potassium permanganate is equal to 338 kilojoules of energy, dot line. To cancel out the units, kilojoules, we're going to put in our conversion factor 418 kilojoules in the denominator, which is equal to 2 moles of potassium permanganate in the numerator. Then finally, to convert to molecules of potassium permanganate, we know that 1 mole of potassium permanganate is equal to 6.02 times 10 to the 23rd molecules. We multiply the numerators together and divide by the denominators, and we get 9.74 times 10 to the 23rd molecules. This tells us that 9.74 times 10 to the 23rd molecules of potassium permanganate release 338 kilojoules of energy. I hope you enjoyed this video. To get more stoichiometry help and your free copy of my Amazon.com bestselling book, Solving Mole Problems, go to purplestoic.com. I'm Melanie Fine, and this is Chem in 10.